We are looking at a laundry list of items that you should go through before you deploy multiple spanning tree protocol within your layer 2 topology. First one on our list is to identify edge ports. Well, I'd like to expand on this and essentially say, let's map out our topology. Let's identify the edge ports. Let's identify the inter-switch connections between our switches. Let's make sure that we're operating in full duplex on those inter-switch connections so we can maximize the benefits that multiple spanning tree protocol gives us with the rapid convergence that is essentially the same as rapid spanning tree protocol. So we need those full duplex point-to-point inter-switch connections. And we want to be able to map it out on paper, identify the edge ports so we can really define the boundaries of our spanning tree topology. Now, when it comes to those inter-switch connections, we really want to make sure, and in reality, it should be mandatory in this case, that the links are trunks and they are not pruning any VLANs that are used in multiple spanning tree protocol. Whoa, wait a second. That's right, I just said they should be trunks and we should not prune VLANs. Why is that? Well, let's examine what could happen if we aren't using trunks or we are pruning VLANs. In our top example here, notice how we have MST instance 1 and we have VLANs 10 and 20 mapped to MST instance 1. We are using trunk links, so that's great. We said let's use trunk links, so we are. But what we are doing here is we're pruning VLANs. Take a look at this. We're only allowing VLAN 10 on this link, and we're only allowing VLAN 20 on this link. Does multiple spanning tree protocol care about how we have pruned our VLANs? The answer to that is no. It doesn't care. It doesn't see that information, so it has no idea it is going on. So here's what happens. We have the instance of spanning tree protocol, instance 1, determining how to prevent the loop here. You see, even though the links are transmitting frames for different VLANs, MST instance 1 says, I'm just in MST instance 1. And in this case, this is a loop for MST instance 1, whereas with rapid spanning tree protocol or per VLAN spanning tree plus, it was on a VLAN by VLAN basis. The spanning tree instance is not in this case. So it's this entire instance made up of these two VLANs. Well, it's a loop. And so it blocks one of the ports. And it doesn't care that I've pruned the VLANs there. So now what is happening? We have just denied VLAN 10 traffic. That's what has happened. We should be allowing VLANs 10 and 20 on this trunk as well as 10 and 20 on this trunk. That way there, when it gets blocked, the other link, the other trunk can be used. So make sure that the VLANs that are supposed to go across the trunks are not being pruned at all on any of those trunk links. But what if we're not using trunk links? What if we're using access ports? That's what we see here, access ports. So we have access VLAN 10, access VLAN 20. Well, again, it doesn't matter to MST because MST1 in this case has both VLANs 10 and 20 mapped to it. So it sees this as a complete loop. And based on the decision-making process, it says, I got to block this here. So even though it's an access VLAN, and in our opinion, in our vision, we can see that there's no loop here because it's two completely different VLANs. MST sees it as one. MST1 with both VLAN 10 and 20, therefore there technically is a loop, according to it. So it has to prevent that loop from occurring. What about if we have VLANs that are in different MST instances? So instead of having them both in instance 1, what if one of them is in instance 0 and the other one is in instance 20, or pardon me, instance 1? So here we have VLAN 10 in an MST instance 0. We have VLAN 20 in MST instance 1. notice we're using access VLANs. If these were trunks, it wouldn't be a problem. But since they are access VLANs, access ports, so this port is for VLAN 20, VLAN 20, VLAN 10, VLAN 10. Remember that BPDUs are only sent by who? The IST instance, instance 0. So instance 0 sees a loop. And what does instance 0 do? Ooh, let's block this one right here. As a result, traffic for VLAN 10 can no longer pass. However, if it was trunk links we were dealing with here, it would be a different story. So the key here to remember when working with multiple spanning tree protocol is use trunks. And number 2, do not prune VLANs from those trunks. Because there's the disconnect between the VLANs that are allowed on the trunk and the MST instances. Because the spanning tree instances are groups of VLANs now. Whereas with per VLAN spanning tree plus and per VLAN rapid spanning tree protocol, this wasn't an issue. Because the spanning tree instances were a VLAN by VLAN basis. It's not that way anymore. So there's a disconnection between the instance now and the VLANs that are allowed on the trunk link. So to prevent any of these problems from happening, use trunks and do not prune VLANs. So next on our list of items is to decide how many spanning tree instances you need and how you're going to map them. So look at your topology that you have drawn. And based on the number of VLANs you have, decide what is the most optimal traffic flow for all those VLANs. And then determine from there the types of instances you will need, how many you will need, who should be the root bridge for each of those VLAN instances, who should be the secondary root bridge for each of those instances. Come up with all of that information. Get it all written down. Choose your region name. Choose your revision number. And make sure that the revision name, or the region name, the revision number, and the instance to VLAN mappings is the same for all of the switches you have. Now, even though you can create multiple regions and come up with a really elaborate, complicated topology, Cisco recommends to keep the region numbers, names, or numbers, so number of regions, to a minimum. Keep it simple. Keep it small. Keep it lightweight. So the fewer number of regions, the better. If you can get away with one region and have all the switches in that single region, do it. That's what you want to do. Because as you have more regions or you have legacy devices, it just gets more complicated because now you're introducing the common spanning tree as well for the complete picture or the complete topology, which would be made up of the multiple regions or legacy devices. So keep it simple. And avoid mapping VLANs to instance 0. So the key here is to create all these different instances, instance 1, instance 2, instance 3, and so on and so forth, and map all your VLANs to those instances. Don't use VLANs in instance 0. Get them into their own instances. When you're migrating, go from the core layer to the distribution layer to the access layer. That's the recommended best practice. And lastly, don't forget about all your spanning tree features. You have port fast, BPDU guard, BPDU filter, root guard, loop guard. They all do the exact same thing as per VLAN spanning tree plus and per VLAN rapid spanning tree protocol. So take advantage of them and implement them to improve the stability of the spanning tree topology.